students, welcome back to your chemistry online class. In today's class we will continue our chapter 4, that is structure of an atom. Till now we have studied about all the types of atomic model, that how we came to know about the structure of an atom. Firstly, J.J. Thomson atomic model, then Rutherford atomic model, and then finally Niels Bohr's atomic model. And now we will discuss how the electrons are arranged in an atom according to Niels Bohr. So our today's topic is distribution of electrons in various shells. What are shells, students? Shells are the fixed energy orbits suggested by Niels Bohr. So we will distribute electrons in various shells. How we will distribute these electrons? First of all, we will use a relation that 2n square will give us number of electrons in nth shell, where n is the principal quantum number, or you can say simply the number which represent the position of a shell. For example, suppose this is nucleus. About this nucleus, this is first shell K. I'll give it value 1. Then for the second shell, that is L shell, the number is 2. In the similar way, the number of n goes on increasing, and we will get our next and next shells. So the number of electrons in a given shell is filled by the formula 2n square. How? For n equals to 1, the number of electrons will be 2 multiplied by 1 square. That means 2 electrons are filled in first shell, that is K shell. If the number of value of n is 2, that is L shell, then the number of electrons will be 2 multiplied by 2 square, that is 2 into 4, it is 8. That means there are maximum 8 electrons which are filled in the L shell. In the similar way, we can calculate the number of electrons in the third shell, for which n is equals to 3. That means for M shell, the number of electrons are 2 multiplied by 3 square. 3 square is 9, so it is 2 into 9, 18. There are maximum 18 electrons in the third shell. Similarly, we can calculate for n equals to 4, that is for n shell, the number of electrons will comes out to be 4 square is 16, 16 2 ja 32. So in this way we can fill the number of electrons in a different shells. One more rule is obeyed when we fill the number of electrons, that firstly we will completely fill a shell and then we will move further. The second rule for the distribution is that firstly we will fill the shell completely and then we will move ahead. That means ऐसा नहीं है कि आपको 2 इलेक्ट्रॉन का डिस्ट्रीब्यूशन शो करना है और आप एक इलेक्ट्रॉन को K शेल में रखते हैं और दूसरे को L शेल में रखते हैं. We will fill the shells in progressive manner, successive manner. Firstly, we will fill the K shell completely. Then we will go on L shell. After filling all the 8 electrons, only then we will move on next shell, that is M shell. So in this way we will fill the shells in successive manner. Shells are filled in successive manner. That means we will start from K shell and then we will move ahead after filling it completely. So these are the three important rules to distribute the electrons in the various shells. For your syllabus, you have to learn first 20 elements and how you can distribute electrons in shells. You have to prepare their chart also in your fair notebook together with the notes. So how we can fill? Suppose I am writing here the elements. The first element is hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. These are the first 10 elements. I write all in serial number like this. So how I can arrange number of electrons for this? Firstly, I must know the number of electrons in that. So how would I came to know? Let's define two basic terms. First one is atomic number. What do you mean by atomic number? Atomic number means total number of protons present in a atom. Total number of protons in an element represent its atomic number, and the symbol for atomic number is Z, and Z is Np. Np means total number of protons. As we know, an atom is electrically neutral, so that means it carries equal positive charge and equal negative charge. So we can also say that Z is equivalent to number of electrons also. एक एलिमेंट का या एक एटम का जो उसका एटॉमिक नंबर है वही उसके नंबर ऑफ इलेक्ट्रॉन्स को भी रिप्रेजेंट करता है, एंड द सेम आर द नंबर ऑफ protons in that atom. So atomic number is either the number of protons or number of electrons. And the second term is atomic mass number. What do you mean by atomic mass? In the previous chapter we have studied that atomic mass means mass of one atom. And here I am writing atomic mass number. That means we will write a number which represent the atomic mass. And this atomic mass number is represented by capital A. And what is capital A? It is equal to the sum of number of neutrons and number of protons present in an atom. The total sum of total number of neutrons plus total number of protons together will give the value of atomic mass number, that is capital A. And now one more thing related with these two, that is representation of an element. So how we will represent an element in terms of Z and A? So what we will do, we will simply write the symbol, and in the left corner we will write its atomic number, and at the top right we will write its atomic mass. So in this way we can represent an element. For example, hydrogen is the element. I am writing here H. Its atomic number is 1 and its mass number is also 1. So I am writing it like this, 1H1. The second element is helium here. For helium, the atomic number is 2 and its mass number is 4. So I will write it like this, 2He4. This is the representation for a element in terms of its atomic number and atomic mass number. So now come on the distribution. As the serial number is equivalent to its atomic number. The elements in periodic table are arranged on the basis of their atomic number, and the serial number is same as their atomic number. So in this way, the atomic number for hydrogen is 1, for helium 2, this is 3, 4, 5, 6, 7, 8, 9 and 10. If the atomic number is this, we can also say that the number of electrons in it is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Also we can write the number of protons. Number of protons are same as that of number of electron. So we will continue our counting up to 10. So these are the number of protons. Now about atomic mass number. Atomic mass number is either the double of atomic number or greater than this. For these elements, the atomic mass number is, here it is 1, then 4, then 6, then 8, then 10, 12, 14, 16, 18 and 20. So if we know the value of atomic mass number, we can calculate the number of neutron also. How we will calculate number of neutrons? We will subtract number of protons from here. So it will be 0. 4 minus 2 it is 2. 6 minus 3 it is 3. 8 minus 4 it is 4. In beryllium the atomic mass is 9 also, so we can write here 5. So 10 minus 5 it is 5. 12 minus 6 it is 6. 7, 8, 9 and 10. In this way we can calculate the number of neutrons also. Then what we will do? We will do their electronic distribution in different shells like this, K, L, M and N. Firstly we have to distribute one electron, so it will be in K shell. Then 2, it will be in K shell also. Then 3. Firstly we will fill the K shell. As we know, maximum electrons can be 2. So next we will write here. Similarly goes on 2, 3, 2, 4, 2, 5, 2, 6, 2, 7 and 2, 8. In this way we have distributed the electrons in various shells like this. From here also we can calculate the valency. What do we mean by valency? Valency means the combining capacity of an atom, and the last electron in outermost shell represent the valency. 1 electron, valency is 1, 2, it is completely filled, so its valency is 0, then again 1, 2, 3, 4. If the number is greater than 4, then how we will calculate valency? We will subtract the number from 8, so its valency will be 3. 8 minus 6, its valency will be 2. 8 minus 7, it is 1. 8 minus 8, it is 0. All these are up to 4 positive, and here comes a negative sign. So in this way we can calculate the valency also from this table. Now move on further. We will write the next element also, and this is as a homework for you. You will write the next 10 elements starting from sodium that have atomic number 11, and you have to write all these terms like this in your fair notebook. And during the distribution of electrons, one more thing students, keep in mind that when we are filling these shells, according to the formula it comes to 8, 18 and 32. But we will fill only 8 electrons in the M shell also. And that is due to repulsion of electrons. So this is the exceptional case, and then we will move on further n shell, and we will fill here 18, and then we will move on. This is the main exception, and you have to keep in mind while you are filling your electrons greater than 10 number or 18 number. So now we will discuss the next topic of atom, and these topics are very important. I'll discuss them in comparative way, that is isotope, isobars and isotones. What are these? These are very simple. What are isotopes? Isotopes are the elements which have same atomic number but different atomic mass number. That means their mass number is different but their atomic number is same. These are named as isotopes. For example, hydrogen have 3 isotopes. It has 1 as its atomic number, but the mass number is different in every case. Here it is Z is 1, A is 1. That means number of protons 1, number of electrons 1, but number of neutrons are 0. There is no neutron. Here in this Z is 1, A is 2. That means number of electron 1, number of proton similar to Z 1, but number of neutron is also 1. So that they collectively form A as 2. And this Z is 1, A is 3. That means number of electron 1, number of proton 1, but number of neutron is 2. Collectively they form A equals to 3. So these are the 3 isotopes of hydrogen, and we name them as protium, deuterium and tritium. These isotopes of elements are very important. They have their crucial use. For like deuterium is used in nuclear reactors as a moderator. The isotopes of iodine are used in treatment of cancer. The isotopes of uranium are used in nuclear reactor to produce the energy. So these isotopes are very important. You can read the further uses of isotopes from your book. Then the next topic. The next topic is isobars. What are isobars? They have different atomic number but they have same atomic mass number. These are isobars. Isobars having same atomic mass number but different Z. For example, I am writing here carbon and nitrogen. Carbon have 6 as the atomic number and 14 as the atomic mass number. Nitrogen also 7 as the atomic number but 14 as the atomic mass number. They have different Z but same atomic mass number. So these are isobars. Now the last term is isotones. Isotone means the elements having same number of neutrons. जिन एलिमेंट्स में सेम नंबर ऑफ न्यूट्रॉन्स होते हैं हम उन्हें बोलते हैं आइसोटोन्स. When we will count their number of neutrons, they will comes out same. So these are isotones like this. Here I am writing the isotope of hydrogen and here I am writing helium. For this Z is 1, A is 3, number of proton 1, number of electron 1, number of neutron 2. Here Z is 2, A is 4, number of proton 2, same as atomic number, number of electron 2, number of neutron 2. So in isotones we don't consider the Z and A. They might be same or they might be different, but we will consider only that they have same number of neutrons. So these are isotones. In this way we have completed our chapter 4, structure of an atom. If you have any doubt, you can ask in the comment section. Thank you. Have a nice day.